for today. I can simplify algebraic expressions using order of operations. I can simplify algebraic expressions using order of operations. Let's read together. 1, 2, 3. I can simplify algebraic expressions using order of operations. So by now you should know what it is to use the order of operations. We've been using those, but I just want to clarify a couple more things today. The second thing is algebraic expressions. I already introduced this some time back, but I didn't do a formal introduction so to make sure that you distinguish one from the other. So now check this out. Pens down, eyes up there really quick. So let's say since I was picking up parties and Saturday Academy slips to be signed, and let's say someone in here didn't turn in either or, Samuel, and he went home and talked to his parents, and he's all, well, you know what, I didn't get these signed, and his parents go like, well, tell you what, here are these signed, here you go, you're going to attend Saturday Academy, and also tell Mr. Q that, sorry for the inconvenience, and we're going to get him, your whole class tickets front row to a concert. So therefore we're like, oh yeah. So then I asked for permission. We all go, but the only catch is that they didn't tell Samuel who was playing. So then we get there, we're front row, there it is, and then all of a sudden the artists come out. Oh, sorry.
Come on, man.
Let me start it again. So we start with this first one. So anyways, yes. So anyways, we're like, okay, that sounds a little, what is it? Country. So guess what? So the first artist that comes out is playing country. However, as soon as the second artist comes out, changes the beat, it changes the lyric. So then all of a sudden it's no longer country. What is it now? Hip-hop or rap, right? Well, in math, it works about the same way. Check this out. Everybody look it up, please. In math, it works the same. These are ways that people express themselves. Some express themselves with country, some with hip-hop. So therefore, in math, it's the same thing. Imagine that the country was a numerical expression. And the same thing, as soon as we add something to that kind of music, like a different beat, it becomes something else. So that something else in math is called algebraic. So let me clarify that. Check this out. So let's say I gave you this, 2 plus 5. This is a numerical expression because it has numbers and operations. However, as soon as this happens, it becomes algebraic. Let me show you another one. 8 divided by 4. And as soon as I do this, it becomes algebraic. Tell your neighbor what's happening. Okay. So some of you right away noticed that this has only numbers and operations, but as soon as they add a variable, it becomes an algebraic expression. So therefore, that's how it is. The same thing. When we went to the concert, we were listening to that country song, right? And then all of a sudden, they added a different beat, and here comes Drake out, and he starts doing his thing. So that it no longer country, it becomes an R&B or a rap song, right? There we go. So with that said, copy this down on your prayer model, please. Algebraic expressions. What are they? Algebraic expressions are expressions that contain variables, constants, and operations. Algebraic expressions are expressions that contain variables, constants, and operations. Examples. Here are some examples. X plus 3, n minus 7, 2 times y, k squared divided by 5. All those are examples of algebraic expressions. Copy that, and then I'll elaborate on it. Alright, so check this out. According to the definition, it says expressions that contain variables, constants, and operations. The constants are basically the numbers by themselves. So let's see. This is an expression. It has a variable, operation, and a constant. Yes, variable, operation, and a constant. Constant and a variable, and this is a coefficient. Here's a variable to the second power, operation, and a constant. Okay, so far so good. So look at these, non-examples. As you're copying them down, think about it. Why are those non-examples? If these are examples of algebraic expression, why do you think these are not? Think about it. All right, talk it over to the neighbor, see what they say. Go. All right, I heard you guys say because these have equal signs and inequality symbols. Is that correct? So expressions do not have equal signs or inequality symbols, but they do have variables, constants, and operations. So once again, they do not have equal signs or inequality symbols. So let me write inequality. But they do have variables, constants, and operations. So far, so good? Okay, underneath that, there's three basic steps, very short steps, but is something that we need to understand and we need to do every step of the way when simplifying algebraic expressions. So here we go. Three basic steps. Write these down, please. Steps. To simplify algebraic expressions, I use the order of operations. Step 2, use tab properties to combine like terms. And step 3, simplify. Step 1, use the order of operations. Step 2, use tab properties to combine like terms. Step 3, simplify. So think about it. Tab properties. What properties are they talking about? Don't say it out loud. Tab properties. Okay. Madeline? Commutative, associative, and distributive. That is correct. We've been using those properties since 3rd grade, so by now you should have them down, right? All right? So copy those steps down. Bless you. So, just to recap, everybody look up, please. So we know the steps. Just use the order of operations, use your properties to combine like terms, and at the end we simplify. So now let me revisit order of operations just to clarify. Here we go. Order of operations. We start off with parentheses and powers. Now that we know that powers are exponents, is that correct? You don't write this down, you're just paying attention. Now to clarify what parentheses mean, it doesn't mean only parentheses, it means grouping symbols, all grouping symbols. So let's see, I'm going to start with the first one that is very obvious, which are parentheses. Is that correct? From there, have you seen these that look like a little box thingy? Those are brackets. From there, have you seen these that look like this? These are known as sets, okay? From there, have you seen this one? Yeah, the radical is also a grouping symbol because it separates whatever's inside from the outside. However, also, how about this one? Absolute value. Also, it separates things that are inside the absolute value with stuff that's outside. And how about this one? Bar. Fraction bar is also a grouping symbol. It separates the numerator from the denominator. So all those are forms of grouping symbols. And we know that, once again, that powers, we know that they are exponents. Are we there? So that's the first thing we're going to simplify when we're simplifying our expressions. The second thing, we're going to multiply and divide. And we always do it from left to right, whichever comes first. From left to right, whichever comes first. And the same thing once we finish our last step, which is addition and subtraction, and we always go from left to right, whichever comes first. Addition and subtraction from left to right, whichever comes first. We got it? Okay, let's do some practice. Copy these down, please. It says, example 1, simplify each expression. 15 minus 2 times 3 plus 1. And B is 12 plus 3 squared plus 10 divided by 2. Let's do that one together. things first, I'm going to write my order of operations. Parentheses, exponents, multiplication, division, addition, and subtraction. Here we go. Let's start with this one. Do I have any grouping symbols? Parentheses? No. Do we have exponents? No. Multiplication and division? Yes, and I'm going from left to right. So check this out. Left to right, scan it, about right here. So negative 2 times 3, that's negative 6. I bring down the 15, I bring down the plus 1, and then my last step is addition and subtraction. We're going from left to right. 15 minus 6, that's 9, plus 1, that is 10. Bless you. Yeah. So far, so good? All right, let's do this one. Here we go. Here we go. Do we have grouping symbols? Nope. How about exponents? Yes, this is 9. I bring everything else down. The 12, the plus, the 10 divided by 2. Okay? From there, multiplication and division? Yes, right there, going from left to right. So therefore, 10 divided by 2, that is 5. Bring everything else down. The 9, the plus, and the 12. And at the end, we're left with addition and subtraction. And I'm going from left to right. This is 21 plus 5, the total is 26. 21 plus 5 is 26. So far, so good? Pretty simple? Okay, let's move on. Here we go. Copy this next one, please. Example 1C says, simplify each expression. 2, open parentheses, negative 4, close parentheses, plus 22, divided by 4 squared minus 9. Okay, so write your order of operations. First things first. PEMDAS. Okay, so let's see. Do we have any grouping symbols? Yes, we have a couple. We have this parentheses and the fraction bar. So which one are we going to start with? The fraction bar tells us to either do the numerator completely or the denominator. I'm going to focus on the numerator. And I'm going to start all over again. Do I have any parentheses on the numerator? Yes, but I cannot simplify anymore. So therefore, do I have any exponents on the numerator? No. So from there, I go to multiplication and division. Do I have any? Yes, I'm going from left to right. So therefore, 2 times negative 4, that's negative 8. Bring over the plus 22. And I'm left with addition and subtraction. I'm going from left to right. So negative 8 plus 22, that is 14. Am I done with the numerator? Yes. So now I focus on the denominator. Any grouping symbols? No. Exponents? Yes. 4 squared is 16 minus 9. We skip multiplication because there is none, or division, and we go to addition and subtraction. That is 7. And at the end, simplify. So therefore, we're left with 2. So far, so good? All right. Copy this next one, please. Here we go. Copy that one. Simplify the expression 8 divided by 1/2 times 3. Careful with this one. This one has a little curveball. See if you catch it. Go. You're going to help me out with this one? All right, so it says example 1A, simplify the expression 8 divided by 1/2 times 3. So I'm going to have Ebony help me out with this one. So let's see. Order of operations. Do we have any parentheses? Exponents. Multiplication and division. Yes, so we're going from left to right. Go. So just look up and go. You hover over so you can find it first. Okay, here, I got it. All right. So, let's see. First, multiplication and division. Yes, right here I'm going to focus on this one. So therefore, this is 8 divided turns into multiplication, and the reciprocal is 2 over 1. Why? Because it's multiplying a fraction, therefore you multiply, it's divided by a fraction, you multiply times the reciprocal. Remember that one? So therefore, this became 16 over 1, which is 16. Bring down the multiplication sign, times 3, so this is 48. Hands if you got that. Okay? Yeah, some of you did. Yeah, I saw you. I saw it. I wanted to so you could show it. All right. Yes, right. All right, here we go. Let's do this next one. Copy this down, please. Example 1, look at B. It says simplify the expression 3 times the square root of 50 minus 1. See if you can do that one by yourself. 3 times square root of 50 minus 1. Once again, follow your order of operations. Go. Okay, so you wrote your order of operations. Here it is. PEMDAS. Okay. So, do we have any grouping symbols? Yes, I'm going to focus on this piece right here. So, therefore, I'm going to bring the 3 down by itself with the multiplication because I'm not going to use that right now. I'm focusing on the grouping symbol. So, what is 50 minus 1? So, we still have square root of 49. Okay. We're still on the grouping symbol. Let's simplify the grouping symbol. What is square root of 49? 7. Bring down the times 3. So, this is 21. Hands if you got that. Okay. Yeah, guys, check this out. Be careful with these because some of us get confused. Everybody look up, please. Some of us get confused with cube root of 50 minus 1. This is not the same as that. Notice that the 3 is over here. That means it's multiplying. Okay? All right, let's move on. Next one. Copy that one. See if you can do that one by yourself. Go. First things first, you write your order of operations. Do we have grouping symbols all over the place, right? But I'm going to use the big one right here, so I'm going to focus on the numerator. Do we have a parentheses on the numerator? Yes, I'm going to simplify this, so this becomes parentheses 7 times negative 8. Do I have exponents? No. Multiplication and division? Yes, so this is negative 56. Can I simplify the numerator anymore? No. Next, let's focus on the denominator. Do we have grouping symbols on the denominator? Yes, but I cannot simplify anymore. Exponents. Yes, that one. That tells us negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4 times negative 2, that's negative 8, minus 3. Do we have multiplication or division? No. Do we have addition and subtraction? Yes, I'm going from left to right. Negative 8 minus 3, that's negative 11. If you don't see it, remember, this is at the opposite of the second number to the first. So therefore, that's negative 11. Are these two the same sign? Yes. So to simplify this, check this out. Guys, focus. How many times does 11 fit into 56? 5 and 1, 11. Hands if you got that. Okay, good. All right. So, now, the next thing, I want to revisit combining like terms. Everybody look up, please. But anyways, before I move on, you're going to have a couple of word problems, but this is fairly simple. Everybody look up. If they give you the expression 2b plus 4s plus 7b, which is this, they should give you values for each variable. So look, what is b here? 10. What is s? 6. And what is b? 5. So when you substitute in there, that's what we call evaluate. Here it goes. It should look like this. 2 times 10, 4 times 6, and 7 times 5. We simplify that by multiplying, so therefore it's 20 plus 24 plus 35. So far so good. And then you just simplify, and at the end you write a statement. Remember to write your statement for the word problems. Yes? All right, look at this next one. Check this out. Look at this. Same thing. You substitute the values, simplify, and simplify all the way with using the order of operations. Okay? So check this out. Hold on. Give me a second. So for combining like terms, once again, I wanted to recap on this really quick. Make sure you focus on coefficients if they have the same type of variable, same type of exponent. So look at this one. These are coefficients, but we cannot add because this is totally different from this one. So that's all I wanted to touch up on. Now, in the homework, you're going to have one of these. Check this out. Look at this one. So, on the homework, you're going to have one that says, use properties and operations to show that 14x plus 4 times 2 plus x simplifies to 18x plus 8. So, you're going to make a table like this. So, copy this table, please. Write statements, reasons. And on this side, copy this expression, please. This is the last one I'm going to give you for the day. Hurry up, please. So check this out. If I was to simplify this, I need to get rid of this parentheses, and it's multiplying. What is that called? When we multiply to both terms? Think about it. Yes, everyone? Distributive property. So you write, over here on the reason, you write distributive property. So this is 4 times 2. You write it out. Everybody look up. And 4 times x. Do you guys see that? Okay. So let's multiply these out. So you write multiply. So what is 4 times 2? That's 8. 4 times x is 4x. By looking at it, don't say it out loud. What would you do next right here? Don't say it out loud. Everybody see it? Don't we move stuff around? What property is that? Commutative. That is correct. Commutative property. So therefore I move the 4x over here and the 8 at the end. And then, in order for us to look at these two, we need to put parentheses around them. What property is that? Think about it. Very good. Associative property of addition. So we put parentheses around it, and then we combine like this. And we end up with that. Did we prove all the steps with properties? Yes, that's what you're going to do when you get to those. So for homework tonight, homework is found on page 51. You're doing number 1 through 41 odds. Okay? So as soon as you turn in your homework on your way out, make sure you bring me those papers signed by tomorrow, guys. Okay? Have a good one, everyone. Enjoy your homework. See you guys tomorrow. Yeah, turn in your homework on your way out, please.